Model optimization. Model optimization aims to improve the model's performance by fine-tuning its hyperparameters, regularization techniques, and architecture. You see now? Now, your model will not be complete if it is not optimized. So, we need to fine-tune its parameters and the regularization techniques and even the architecture of the model. So that the model will work efficiently. So what is hyperparameter tuning? Now, in hyperparameter tuning, you adjust the hyperparameters. Now, these hyperparameters are learning rate, even regularization parameters, the batch size, the number of layers, to be able to optimize the model performance. Those are hyperparameter tuning. You will need to look at the learning rate. You adjust it. You look at the regularization parameters. You work on that. The batch size. You either increase or decrease it. And even the number of layers. All these things, when they are properly done, they optimize the model's performance. Now, in hyperparameter tuning, you can use techniques like grid search, random search, or even Bayesian optimization. They can be used to search the hyperparameter space efficiently. Another technique is regularization. So applying regularization techniques such as L1 or L2 regularization, dropouts, or early stopping to prevent overfitting and improve generalization. So regularization is usually used to prevent overfitting. It normalizes your data, it reduces the model complexity, and preventing it from memorizing noise in the training data. Now, another task in optimization is model selection. Now, compare and select the best performing model among different algorithms. So, you will now consider factors such as training and inference time. Those are the things that you are going to use in order to select the best model. So, you have to consider factors such as inference time, 1, interpretability, 2, and also trade-offs between performance and complexity. Then in your optimization, you can also do ensemble methods. Ensemble method, you combine multiple models to form an ensemble and layer and leverage their collective predictions. So by the time you are combining multiple models, so this will optimize your model. So ensemble method like bagging, and this bagging like random forest and boosting. Your bagging can be random forest and your boosting can be gradient boosting. They are very common ensemble methods that you can use to improve the overall model performance. And then make sure that can also be used to reduce variance. Now, another optimization task is transfer learning. Utilize pre-trained models on large data sets. In your transfer learning, you have to, what you have been able to train, transfer it to on a large data set to check. And whatever you are going to use must be similar tasks to initialize the model's parameters. So transfer learning can speed up training and improve performance, especially when the available training data is limited. Another optimization task is model regularization. So you apply techniques like early stopping, dropout, or batch normalization to prevent overfitting and improve model generalization. That is model regularization. So early stopping stops the training process when the validation performance starts to degrade. When you notice that the validation performance begins to go down or begins to drop, you do early stopping. Now, when you do that, you are preventing the model from overfitting. Another optimization task is model interpretation. Gain insight into the model's behavior and decision-making process. Now, you can use techniques like feature importance analysis, partial dependence plot. This will help understand the model contribution and identify influential features. If you don't do all these things, your model will not be optimized. We are talking about efficiency. For instance, like take techniques like feature importance analysis now. We'll be able to tell you those features that are relevant for your model. So this, by so doing, it helps you to optimize your model. So model training, evaluation, and optimizations are repetitive tasks, or what we call repetitive or iterative processes in machine learning. So by carefully selecting appropriate training techniques, evaluating the model's performance, and optimizing its parameters, if you do that, you can improve the model accuracy, robustness, and generalization capability. So it is important, in summary, to strike a balance between underfitting and overfitting to ensure the model performs well on unseen data.